Hi guys, Mr. T here. Today we're going to look at solving linear / quadratic systems. It means taking more than one equation and seeing what they have in common. And it says, how can I solve a system composed of a linear equation, which is a line, and two variables, and a quadratic equation that's kind of like a U shape, and see what they have in common. So that's what we're going to be doing here. But before we do that, I want to step back a little bit and refresh our memories on something that we've already done. In the past, when we solved these quadratic equations by graphing just a single quadratic equation, we decided to take the left-hand side and put that into y1. We're creating the two equations. Okay, it's not a system, we're creating it, and then put the other side 12 over there. So that's one way we can make that happen. And so let me start off. I'm going to graph, see if it'll behave itself. Okay, let's see. Let's start off by graphing the 12. Okay, so that one's pretty straightforward, but to get this guy, I'm going to need some more points than that. Okay, so put that. We don't need that just yet. So I'm going to need my calculator to kind of help me out. So I've already got this guy put into the calculator, and since it's got a 12 here, my normal standard screen is not going to work. So over here in the window, I'm going to go from -5 to +20 on the up and down so that I can see the horizontal line crossing through like that. Otherwise, it would be just out of the screenshot there. Okay, so this one's got the cross line going here, and sorry, my colors don't match with what I'm doing the other. So, but that's okay. Now, how am I going to get the points to do this problem? So here we're going to go hit second graph. Here's my tab. Woo! I'm pretty sure -560 is not going to be very helpful in my graphing. Okay, but I do have these points. Okay, see what ones I can't. No, that one's not too good. Hey, but -2, 12, -1, 4. Okay, I can do those, and I've got those written down on another spot here, so I can use those to make that happen. So I'm going to slide back over here and see what's a green. Okay, and use these points. So my first point I want to do is -2, 12. So -2, 12. Okay, so you plot that point. The next one is -1, 4. Okay, and then 0, 0. Then it says 1, 0, 2, 4, and then 3, 12. And that's all well and good. But where's my vertex? Well, I'm not seeing it on my chart, but I can calculate it. So let's go back over here and see what that vertex would be. So hit second, calc, and it is a minimum, so it's a 3. So let's go slide over here, go to the left of my vertex, because that's what it says, left bound. So get on over, come on. Get her, get her, get her, come on. Slow, slow, come on. Easier when on your hand one though. All right, so now I hit enter because it's a left of it. Now it says right, so I need to go to the right of my vertex there, which is the minimum in this case. And then I hit enter, guess, yes, and there it is. 0.5 is what that rounds to, and then -0.5. Okay, so that's going to be right smack in the middle. All right, so now I can draw my line. It's going to be a little bit more challenging here. All right, and then that's going to come on down here through these points right here. Okay, so not too bad, but now I need to solve this thing. And so we said that this spot right here is x equals -2, and that spot right there is x equals +2. Now, what is the solution? The definition of solution again is that which you can plug in that makes it true. Can I plug in -2 into this equation? I can, because I have x's that I can do that with, and it would turn into 12. If I turn a positive, put +2 in for these two x's, would that also turn out to be 12? Sure. But what about my y value of 12? Well, if I plug a 12 in for those two x's, number one, it's an x, not a y. Okay, we created the y. So when you have one original equation, you create two, your answers are just plain x. But that's not what we're going to be doing in this section. Now, are we going to graph the same way? Are we going to calculate the same way? All of that is exactly the same. The only difference we're going to have is the kind of answer. So if you actually start with two equations, which is what a system is, your answers are going to be points because you need two variables, which is what we said from the very beginning. What did it say? Two variables. So it's going to be exactly the same steps that we've done previously, except our answer, instead of just being x equals a number, our answer is going to be a point, an ordered pair, x and y. So let's go do some examples and kind of get that point across, okay? So in our book that we're currently using, this is our first example here. A system, it means we got two equations at once. And they weren't very nice. They didn't have them equal to y for us already to make it easy to graph. So, but we do see that the first thing to make it easier to graph is we solve for y. And so that's where these guys right here. So we solved the first one for y. We solved the second one for y. Okay? And let me back up here. Let's put this one in blue. All right, so I wanted to put the second one in blue. That's all right. So that means that the parabola is the second equation, and the line is the first equation. Okay, so what are we looking for to solve it? So we graph the line, we graph the parabola. Okay, it makes sense. Remember that this is down 6 and left 1 from the vertex there, right there. And we're going to find that where they cross is right there and right there. And that's about where those points are, right? And as far as we're concerned, that's about as good as we can get just looking at this graph. It's a little bit of a guesswork, okay? But they say there are some exacts. If you use some algebra stuff, we can find that, or if you use your own calculator, you can do this. And that's what we're going to end up doing, okay? We're going to find the exact values from the graph using our calculator. But this gives you an idea. If I got negative 1.37 on my calculator, but it looks like negative 1.5, that seems reasonable. But if I get negative 3.3 and it looks like negative 1.5, something went wrong, right? And that would be an indicator that you need to go back and double check something. So, but that's the process. We're going to get it equal to y, graph each, and look for where they cross. And again, the solution is going to be an ordered pair because to plug it back in, we need an x and a y. So let's go through this process in more detail. So here's the same thing. Let's show how this is going to be graphed. So go to our graphing calculator and we type that information in. So here's our graphing calculator. I already have those in. So I'm going to hit zoom 6 to take a look at our picture. Very similar to what we had a moment ago. So now we're going to need to graph these two pieces. Okay, so let's start with the line. Oh, and that one's easy. We don't really need the calculator for that, but that's all right. Let's see. So the line was in blue, the other one was in red. So let's see if we can't keep that matching. So we'll do the line in blue. And so our y-intercept is -3. Right about there. And we have a slope of 2. So up 2 over 1, up 2 over 1. And we just keep that guy moving. I want to go far enough that when I use my little graphing line tool, it'll look right. So now I can grab my little line tool and start here and sling it all the way up to there, and everything should land where it's supposed to. Okay, let's go back to my pen. We'll turn it back to red. But what points am I going to do for this graph? Well, I can tell you right now that the vertex is going to be left 1, down 6, right there. That we can tell for sure because it's in vertex form. And then we're going to have it stretched by 2. So I'm going to let my calculator help me out with that a little bit. And I can do some of those without that, but we're just going to use our tool that we have. So second table here. And so we got -5, 13. Okay, and then 4, -11. And we're going to graph these numbers. Okay, and so I'm not going to go back and forth. I have those written down, so I'm going to graph those, but you can grab your own calculator and do that with me if you want to. So -5, -13. So -5, -13. So there's 12. And so there would be 13. So hey, how about that, right? Oh, wow, that's interesting. Huh. And then, well, that's because it's the line, like a crazy person. I'm supposed to be doing the parabola. So no wonder it was on the line, because it is the line. Okay, so -526, not a good choice. How about -412? I think we can do that. -4 +12. So up here. Didn't seem right, but I was going with it until I figured out otherwise. Then -3, 2. So -3, 2. Then -2, -4. Now this is making sense. Yeah, this is all coming together. And then we have our vertex here, and then we come back up. Okay, and we get our corresponding points. Makes it real easy to match up. We can play connect the dot. Okay, trying to be really careful to be as accurate as we can. We humans have difficulty sometimes, but we do the best we can. Works out okay normally. Okay, so what are we looking for? We're looking for that spot right there and that spot right there. So that's the part we're going to calculate on our calculator. So let's look at the graph again. So we hit second, calc, 5 for intersect. And for our first one, we just generally do enter, 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 and that gives us our first point, which in this case is 0.63, excuse me, 0.366 and -2.268. So you know what, make it even easier in the future, we'll put that rounded off to 3 decimal places. So 0.366 comma -2.268. So that's one solution. Then I put that in the wrong spot, didn't I? That goes over here. Okay. So I can have something else go for that spot. So go back over here and calculate. So hit second, calc, 5. But before we do anything else, I'm gonna hit the down arrow here and jump over to the blue line. Oops, okay, that's fine too. Get to I'm closer to the other intersection, and now it should jump just right. Okay, so this is a very similar point. So -1.366 again. So -1.366, comma, and then -5.732. -5.732. -5.732. Good grief. Those are some crazy numbers, but that's how that kind of goes. You're going to get it solved for y, graph, then calculate where they intersect. And in this occasion, you're going to do the ordered pairs. Those are the solutions. And don't forget, if you don't draw the arrows and tell me what they are somehow, you've only graphed. You haven't solved. That's the part that's solving or communicating to your person who's looking at your work that what the solution is. So we got some other examples, but that's pretty much the deal for each one. So you got to solve for y first. So we bring the 3x over. Let's check here. Which one was which? First one is blue. The second one is red. So we'll stay with blue for our first equation. So it's y equals negative 3x plus 4.5. Of course, we got a crazy decimal in here. And then the next one's already solved, okay, for y. So that's not too bad. We got x minus 3 squared. Okay. Now we're going to go to the calculator, okay, and put these in. So here we are in the calculator, already have those typed in. And so now we can hit zoom 6. And here's what they look like. Well, this is a very interesting thing. So here's our line, and then here's the parabola. So it looks like, is it got a whole bunch of points, or maybe is it just one point that they have in common? I think we're going to only have one solution in this case. That's a possibility. That's one of our options. So, but let's get the graphs done first. Okay. So I like to do the lines first because they're quick and easy to do because we got that slope intercept one going. It's a little bit more challenging because we're like at half points on this thing. So we're going to do this in blue. So we come up to 4.5. Okay. And it says negative 3. So go to half spot 1, half spot again 2, half spot again 3 over 1. Okay. Now let's stop before we go any further. It's a negative 3 slope. Is that going downhill from left and right? Yes, it is. So we're doing good. So, okay. 1, 2, 3 over 1. Okay. Again, in that half spot. 1, 2, 3 over 1. 2, 3 over 1. And that's a lot of points here, but the better 1, 2, 3 over 1. The more points I have, the more accurate my graphs can be. And especially on this one, you're going to have to be real careful about that. 1, 2, 3, left 1. 1, 2, 3, left 1. We'll do one more just for grins and giggles, and boom. Now I can go to my line tool and feel pretty good that I have a nice, accurate line. Okay, yeah, that looks pretty good. So there's the line. Now for the parabola. So I'm going to my red. Now, because it's in vertex form, I can figure out the vertex pretty easily. Does it go up and down? No. So it's going to be on the x-axis, right? But it does go right 3. So it's going to be, the vertex is going to be right here. And that 1/2 means it's going to be a compression. So we're going to take the standard parent function and it's going to be compressed. So it's going to be a little wider than some. And now I'm just going to go to my calculator and let it help me with some points. So I'll go second graph, which is my table, and see what I can do to find me some good points here. There's not a lot of good ones here to work with. So I'll tell you what I'm going to do. I'm going to hit mode, and then I'm going to come down here for 1. Go to my float, and I'm going to put that on 3 decimal places. I think that's a good idea. Then come down here, and well, one other thing, I always want an A plus BI. That's just something I like. And then I'm going to come down to answers, and I want to make sure it gives me decimals. So now I'm going to quit out of my mode, and go back to my table, and now it's giving me some decimals. And so in this case, I kind of want some decimals, okay? I kind of want some. So we're going to graph these guys the best we know how, okay? So I have these over here as well. Get my settings to agree. Okay, so let me go back to the graph. We're in red. So my first point is negative 532. Now, I don't think that's going to fit too easily. About negative 424, 0.5, negative 318. Let me see, negative 3, there's 14, 15, 16, 17, 18. Yeah, that fits. Okay, now negative 2, 12.5. So negative 2, 12.5. Okay, negative 1, 8. There. Oof, it's real close, but not exactly. And then 0, 4.5. Okay, look at that. It's right there. Exactly. And then we go to 1 over 1 up 2. Well, then that's not touching anymore, is it? And then we go over down to 2, and that's 0.5. Okay, and then we go to 3, and that is 0. Well, that should be 0. I put, whoops, undo that. So let's do it this way. We're gonna put that there, and that should have been right there, wasn't it? That's 3. There we go. That's 3, 0. I was going by twos for some reason. Okay, and then 4.5. Okay, and okay, now we got our corresponding points. 5, 2, 6 is 4.5. 7 is 8. 8 is 12.5. And 9 is 18. Now, there's a whole bunch of points because we're trying to be as careful as we can, to be as accurate as we can on this situation. So it would appear that we only have one point of intersection, and that's right here at the 0, 4.5. That's what it would look like. We have a pretty accurate graph in our drawing, it looks like. So let's calculate on our calculator and double check ourselves, okay? So come back over here, look at our graph again. There's, okay. So we hit second, calc, 5, enter, 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 and there it is, 0, 4.5. Let me move, whoops, second, calc, 5. Let me try this again, but this time I'm going to move my cursor over here some because it looks like it, in some ways, it looks kind of like it crosses there in two places or something, maybe. With the graphics, it's hard to tell. It's not going to happen, but it doesn't hurt to double check. So we can enter, 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 and again, we still get that same point. So that helped me double check and make sure there wasn't another spot of intersection that I couldn't tell for sure just because the graphics were not, easy. I couldn't zoom in enough. So there it is. 0, 4.5 is our solution to this system of equations. So that's solving it by graphing. So it takes a couple of steps to work through that and to put all that in. But the process is really not all that tough. It takes me longer to do all this work than really as far as than the difficulty is. I have listed here 2 more examples. So I strongly suggest you stay with me for this next example. Anyway, and if you feel good about it, then you might can pause it and move on. But then I'll have another example too for those of you who want to see it, it helps to see more examples to see this process. Okay, so we got to solve these for y. So we take my first equation, move that 3x over, so that's going to give me y equals negative 3x plus 0. Well, there's no point, but I'm going to write plus 0 because that might help us see where some things anyway. And then we bring this second equation is y equals negative 3x squared plus 6. Okay, so let's graph our first one. It's got 0 as our y-intercept. It's got a negative 3 slope, down 3 over 1. That is going downhill from left to right. No 0.5, so this is easier to count. 1, 2, 3. 1, 2, 3. 1, 2, 3. And come up. And there. Now, slide over here and put in our line. Okay. And then for this other guy, I'm going to have to do some little bit of work, but I already know what my y-intercept is going to be. I mean, not my y-intercept, my vertex, because it's going to go up 6 here. So up 6 and nothing left and right. So there's going to be my vertex. Whoops, I got to get my pen, not my line. So my vertex for my other guy is going to be here. And since it's negative in front, it's going to open down. But I want to let my calculator help me do some of the rest of it. So let's go to my calculator. Okay, so here it is in my calculator. Put that in there. And now let's go look at our Zoom 6. Look at our picture real quick. There's our line. Okay, so this opens down. And it does have a vertex right there at the 6, like we'd already mentioned there. And so those points look like I might be able to figure those out just from my table. Let's look at the table. Second graph, look at the table here. And sure enough, look at that. So on the line, we have a negative 1, 3. And on the, see the red part, that's the parabola, right? Negative 1, 3 as well. Since they share that point, that means it's the solution, right? So we've already figured that one out. That was pretty good. And then 2, negative 6, and 2, negative 6. So in this case, we're not going to have to do the calc feature because it came out to be nice, easy points. But we do need to finish off our graph and make sure everything's done in all proper order. Okay, so we got the line. Now we need to graph the parabola. Okay, so here's our points here. So let's jump over to this guy. And so, okay, negative 3, negative 21. It's going to be tough to graph that one. So I would say we'll go ahead and put it right there anyway. And then it's a negative 2, negative 6 right here. And then negative 1, 3 right there. Okay, you see where they have that in common already. Then you got your 0, 6, and then you got your 1, 3. You got that corresponding points, and then you got 2, negative 6, and then 3, 21, which we're going to say somewhere down there. And it's tough enough on paper to get this kind of straight, let alone using this little thing. I got to look at the screen to do it. I'm not looking at my paper kind of thing. So, hey, not too bad. And so our solutions are 2, comma, negative 6. And then our other solution there, where it's supposed to cross, would have been negative 1, comma, 3. And so we're saying if I plug a negative 1 into my first equation, it's going to give me a positive 3. If I plug a negative 1 into my second equation, it's also going to pop out a positive 3. That's why they share that point. We're also saying if I plug a 2 into the first equation, it's going to give me a negative 6. And if I plug a 2 in the second equation, it's also going to give me a negative 6. Because that's what a solution is. That what you can plug in, it makes it true. And in this case, we need to plug an x and a y to make that happen. And so it was really great that you could see that looking at the table here. It was pretty cool. Oops, it didn't like me trying to draw on it. Oh well, on the calculator. So I got one more example if you to do for you. Okay, so here's this guy to go. We got to get it to y equals. So I'm going to use the first equation. I'm going to put y equals 1/2 x minus 3 squared minus 1. So that's in vertex form, so that'd be good for us. And then our second one is a linear equation because it doesn't have any exponents bigger than 1. And so, okay, so if this may take us a couple steps to make this one come over here. So if I bring my y over, that would give me x equals 6 plus y. And then I brought my 6 back over. That would be y equals x minus 6. Okay, so all right, that'll work. Got a couple steps to get that one straight. All right, so in this case, we have the second is the line. So I guess we'll start with the line again. So we got a -6y intercept and a +1 slope. So that makes it easy. So when I like to get, especially with the little electronic line tool I have to start on the end point. If you have a ruler, you can start in kind of the middle and draw out either way. But with my tool, I have to start way out here and come in. So it's part of the reason I go that far out, and then I can come. And the more points, the more sure I can be that I'm drawing it well, because you can get off by just a little bit. Then it causes all kinds of troubles later, doesn't it? Just for being a little bit off. Come on, man. There we go. All right, so there's that guy. Hope I drew it long enough. Let me see. Oh, we haven't put in the calculator yet, so I don't know. We'll have to do that in just a second. So in this guy, I'm going to go ahead and put the vertex because we don't need the calculator for that. So our vertex is going to be what? Down 1 and right 3. So down 1, right 3. So there's our vertex. So and it's well, that's interesting. Anybody got a problem here? I was thinking that maybe it should be a negative in front, but it isn't a negative in front. I wonder what that's going to mean. Well, let's go to our calculator and see what we can do. Okay, so got these put into my y equals. Let's go take a look. Zoom. 6. Okay, so that is why that was looking kind of strange at us. These don't cross at all. So what is this? No solution because there's nothing in common. There's no solution. So that's going to be our answer is no solution. There is nowhere where they have the same x and y's in common. But we do need to finish doing the graphing part to show that and then write the answer next to it. And so, okay, we already got our vertex in place. Now we need to come over here and get our ordered pairs so we can graph off the rest of the parabola there. So here's our things. Going to quickly memorize them, or I actually have them written down. So, all right. So let's get to the graphing piece. Let's get the blue here. And so, -6, 12. Okay. And then -5, oops, excuse me. Again, I grabbed the wrong one. I grabbed the line ordered pairs. So let's go back over here. Yeah, -639.5, not helpful. -531, no, no, no. Hey, -2, see, -317. I think I can probably pull that one off because I happen to have a really long grid. So there's a 15, 16, 17. There we go. And then -2 is 11.5. So right there. negative 1, 7 here, 0, 3.5, so 3.5, 1, 1, 2, negative 0.5, then 3, negative 1, then 4.5. Now we can use our corresponding points to match this guy up. Get them all fixed up nice and pretty, nice and balanced out. So you might not have room enough. You're not using a whole or half a sheet of graph paper to make this happen. That's how you graph. Plot points, play connect the dot. And then since these do not cross, what is our solution? No solution. So that is the answer. Okay, so there's several examples. Takes several minutes to kind of go through those. But that is solving linear/quadratic systems. It's the same skills, graph, see where they cross. We've already got all that done, except some different shapes a little bit. Instead of having the line go straight across like that, it's kind of going in, kind of some angles and such. But we're good. How can you solve systems composed of a linear equation and a quadratic equation? Graph them and then calculate where they cross, if they cross at all. Hope that helps. Let me know if you have any questions. Bye.